Okay, we're going to start with, it's going to be a little much more challenging question we're looking at today. I did the basics yesterday, so I'm hoping we're going to be able to survive with a little bit more challenging questions. Okay, we're starting with the first question. It says, in the diagram, ABCD is a cyclic quad such that AC is perpendicular to CB. It's in the diagram, as you can see. And AD is produced to M such that AM is perpendicular to MC. It's on the diagram. And they tell us let B equal to X. If I look at this diagram, the first point I want to make to you is equal chords. If I use the word equal chords, can someone quickly complete that statement for me?
Don't they subtend equal angles, sir?
How many of you knew that?
Yes, sir.
Very
Yes, sir.
good. So if you look at this diagram, you'll notice that DC all right, let me just get I'm using the wrong stylus here. I'll be with you now. So if we look at this diagram here, you tell me, we just spoke about equal chords subtend equal angles. Which angles will be equal?
A1 and A2.
Somebody said A1. Can you see that? If
A1 and A2, sir.
well done. The angle opposite that chord is A1. It produces A1 from DC. Can you see that? I just want to draw
Yes,
this
sir.
in. And if we look at the other chord that it's equal to, it's CB. So immediately we can all conclude that A2 is equal to A1. Very important point. But I'm going to take that out now. I wanted to illustrate that point because that's like a misstatement that most boys don't use in geometry. Okay, coming to the question at hand. We want to prove that MC is a tangent. Let's get MC. So we want to prove that MC, it's a tangent to circle C. Looks like a tangent. Surely it will be a tangent. But how do we prove that it's a tangent? You tell me now.
So we can start off by saying A2 is 90 minus X.
Okay, before we give me the answer, what are you trying to prove?
So that
I'm just trying to prove
MC
A2 is equal to
equal to A2.
Very good. We're going to try and prove the tan chord theorem, that the angle between a tangent and the chord is equal to the angle in the alternate segment. Agreed?
Yes, sir.
All right. So which angle are we looking at? Let's get this diagram right first. Sorry. So we want to try and prove that this angle here, call it C1 and 2, should be equal to B. What is angle B?
X.
X. So we're trying to prove that C1 and 2 is X. I wanted a strategy before I started. Okay. So now we can carry on. We want to try and find C1 and 2. So in order for us to be able to do that, now you can lead me. I want more discussion today. What do we do first? Where do we start?
So we do not start with A2.
Okay, you want to start with A2. Very good. What is A2?
Pardon, sir.
What is A2 equal?
90
your
mic. So I can't hear you properly, sir.
You can't hear me properly. Sorry, man.
We can't hear you properly, sir.
Can you hear me now?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir, now I can hear you.
Yes, sir.
All right.
90 minus.
Okay, somebody said A2 or 90 minus X. And the reason is, if one angle is 90, as you can see, if one of the angles in a triangle, we're using some angles of a triangle. Let me change that color. So if this angle is 90 and this angle is X, 180 minus 90 is 90, the remainder has to be 90 minus X. Very important to remember, whenever you got a right angle triangle, if we call this X, this has to be 90 minus X, agreed? Converse,
Yes.
if that's 90 minus X and it's a right angle triangle, what will this angle be? X. Does that make sense what I'm trying to show you? Can you hear me now?
Yes,
Yes,
sir.
sir.
All right. So in other words, what I'm trying to show you some strategies, whenever you see a right angle triangle, and I call this to be 90 minus Y, what will this angle be?
Why?
Why?
Can you see that
Would it be
quickly?
wise, sir?
Yes, some angles of a triangle.
Triangle.
You don't have to show the calculation and do the subtraction. But anyway, coming back to our question. So we all agree that we got this angle to be 90 minus X. Where are we going from there?
A1 is equal to A2.
But why is A1 equal to 90 minus X?
Because
Angles
those
in the same-
angles
It's in the same chord.
Angles in the same
Huh?
chord. I haven't heard of
Subtend
that
the same
reason.
chord, sir.
Sorry,
Yeah,
sir.
that's
Equal chords
So,
subtend
equal
angles.
chords subtends
equal
equal
angles,
angles.
sir.
Yes.
That one there, sir.
Right. So we want to say equal chords. Are you happy with that?
Yes, sir.
Now, remember what is my goal? My goal is to get to C1 and 2. Always remember what my goal is. Now look at the right angle triangle I just showed you. Can you see what I just started to show you? Can you pick it up now? What will C1
Oh, yes,
and
sir,
2 be
C.
equal to?
X.
That's 90. That's 90 minus X. Therefore, this angle has to be what?
90.
And we just proved it.
Sorry, sir.
Yes.
So when you say equal chords, what do you mean, sir?
Can you see DC is equal to BC?
DC is equal to, yes, sir.
So equal chords subtend equal angles. So if I take any two chords in the circle, and if I said
Sure.
this chord was equal to that,
Yes, sir.
so from the endpoints, I can produce an angle anywhere I want to.
Oh,
It
okay.
means this angle will be X and that'll be X because equal chords subtend equal angles.
Oh, okay.
All right.
Okay.
My diagram is
Thank
not
you,
too
sir.
clear. Then, right, let's move on. How would we write that out? That's very important. The write-up is very important to me, okay? Because you got to write this proof out. So in this question, you would have started off by saying A2. What would your reason be here?
Equal chords, sir.
No.
Some angles of a triangle, sir.
Very good. A2 is 90 minus X, some
Oh.
angles of a right angle triangle, if you're going to be more specific. Then to find A1, that's the one you say equal.
Chords subtend equal angles.
And now to find angle C1 and 2, the actual name there is MCA. What will my reason be here?
Angles of a triangle. Sum of angles
Some
of a
angles
triangle.
of a triangle. Are you happy?
Yes, sir.
And then therefore,
MC is a tangent to circle C.
so we got MCA is equal to X, angle B is equal to X. Why is angle B equal to X?
Because it
Given,
was
agreed.
given. So,
Therefore,
sir.
now I want to conclude that angle MCA is actually equal to angle B. And therefore, copy and paste the question. MC is a tangent. And you copy it as it is. And your reason here will be, well, we just proved the tan chord theorem, all right?
Yes, sir.
Not prove, we're using it. And you type in converse on the top. So we're using the reverse process. It's not a tangent because we're proving the tangent, and what we're using is the converse of the tan chord theorem. Are you happy with that?
Yes, sir.
Okay, let's move on. Oh, sorry. We stopped there. Let me get my board erased. Right, start thinking about the next question. All right, we want to prove similarity. ACB, and MCD. Okay, now, to be able to prove that. Oh, I used a different technique there. I just realized that on my PowerPoint. I found D2 to be X, and then I went 90 minus X and used C2. Okay, we won't use that one. It's fine. The first one is fine. Both will work. Right, let's take that out now. Okay. Okay, let me just go through it. The one I use in the PowerPoint is different from the one we spoke about, all right? Just to show you, you see D2 is equal to X. Why is D2 equal to X?
Exterior angles of a cyclic quad.
Very good. It's the exterior angle of the cyclic quad. In other words, D2 is equal to that X. But if you look at triangle DMC, if angle D2 is equal to X, surely C2 has to be 90 minus X because M is 90. Some angles of a triangle. Are you with me? And therefore, I can say that
How
C2,
is it exterior angles?
sorry. Therefore, I can say that C2 is equal to A1. Therefore, it makes MC a tangent. That's another way to prove 10-1-1, by the way. Okay. But anyway, our next question sorry, not that one. Okay, our question that we're dealing with is 10-1-2 now. Can everyone see 10-1-2?
Yes,
We want to prove that triangle ACB, what you see in red, is similar to CMB. So we need three things. Am I right? Number one, what can you say?
So, sir,
DMC is equal to ACB. MC is equal to ACB.
DMC, well done. Okay. So in other words, it's called angle M. We can say angle M. You can't see anything now. My PowerPoint went away. Am I right?
yes,
Did it
it's
come
fine.
back?
sir.
Did it
It's
come
back, sir. Yes, sir.
All right, we're back in action. So let's see if anyone's trying to join. Okay, we're fine. Right. In this question, I think we're at the point where I highlighted it. All right, number one, somebody told me, and then I stopped them, that angle M is equal to C. Well, we don't have a name. You can call it C3. Why not? You can label your diagram C3, which is actually equal to 90. What's your reason there?
given, sir.
Given. I'm happy with given. Number two.
So we could say that
D is
C2
equal to B.
Sorry.
D is equal to B, exterior angles of a cyclic quad.
D2 is equal to angle B. Well done. Exterior angle of a cyclic quad. You can finish the reason. And number 3, what's the missing angle? If we go to the blue triangle, the missing angle is C2, and the missing angle in the other triangle is A2. And here we can use some angles of a triangle. And we just proved it's similar. Now, I know this is not part of the question, but I want you to write it down. If these two triangles are similar, what will your ratios be? Oh, by the way, you got to say they're similar and you got to have a case. What's a case for similar triangles?
Angle,
Angle,
angle.
angle, angle.
A. Okay, what are the ratios that can come out from here?
So AC over CM,
AC over CM. Carry on.
CB over MD,
CB over MD. Carry on.
AB over CD.
And I think your reason will be similar.
Prop inter. Oh,
What? Prop int. You're taking a chance. You're writing tomorrow. Similar
Oh, sorry.
triangles.
yes, sir.
Okay, now. That's not the question. We should have stopped at that point, but I just wanted to write the ratios. We may need it in the next question, and I'm moving to a new PowerPoint. Okay, we're done. Now, let's go to 10.2. It says, hence or otherwise prove that CM squared over DC squared is equal to AM over AB. Oh, that's now a good question, am I right? Are you ready to start?
Yes, sir.
Where do we start?
So you look at your ratios, sir.
All right, let's go to our ratios. Okay, I want to go one. Would you mind if I go one back? All right, just take down the
Yes,
question here.
no,
We're
sir.
trying to prove that CM squared over DC squared is actually equal to AM over AB. That is what we're trying to actually achieve. So, what did we learn in the previous question? Okay, let me take you back. We learned that AM over CM, agreed, is equal to CB over MD, which is equal to AB over CD. Which two ratios am I interested in for this question?
Pardon, sir. Sorry, sir, can't hear you.
Okay, sorry, let's go back to the ratios. Can everyone see the ratios we proved? Okay, now let's come to our question.
Yes, sir.
If you notice these triangles, if you look a little closer, we proved that the blue was similar to the, we proved that ACB was similar to the blue triangle, DMC, am I right? Yes or no?
Yes, sir.
But did you notice that triangle AMC is also similar to ABC? Look at it. Okay, let's get a starting point for you guys. If we look at BC over MD,
Yes, sir.
We can't
BC
hear you
over
well, sir.
MD is equal to AB over DC. Where did I get that from?
The triangles. Sir.
ACB, can everyone see ACB is similar to CMD? Would you agree with that? Is ACB
sir.
similar to a CMD? Let's start there.
Yes. Sir.
So let's start with the ratios. We know that BC over MD is equal to AB over DC. But look at the top there. They told us something very important at the top. That DC is equal to what? CB.
CB.
Let me highlight that as well. Okay, so remember this point here. BC over MD is equal to AB over DC. Let me go one back for you. There's it here. We wrote it down. Can you see in this one? We said that BC over MD. Agreed?
Yes, sir.
Did you write these ratios down?
Yes.
Doesn't look like you wrote down these ratios, huh? Okay. Now remember the last question, we proved these two triangles similar. Okay, let me write it down because maybe some of you are confused. What are the ratios that came out from here? AC over
CM.
CM is equal to
CB over
Or we can write
MD.
alphabetical order, we can write BC, am I right? Over MD or DM, any one we can use, all right? And which is actually equal to AB over DC or CD, whichever one you want, all right? Are you happy with that?
Yes, sir.
Right, those are the ratios. Now I want to take the last two. That's what I'm taking here. BC over MD is equal to AB over DC. Are you still with me?
Yes, sir.
All right. Now, let's carry on our journey. So we can now replace BC with what? Because on the top, they told us BC is equal to CB.
CB, yeah.
Sorry, CB is equal to DC. So where I've got BC, I'm replacing it by DC. Because here they tell us it's equal. Still with me?
Yes, sir.
Now, can you see DC times DC is what? Cross multiply. DC times DC is DC squared is equal to AB times MD. Yes or no?
Yes, sir.
All right. Somewhere, we're getting somewhere now. People are starting to see some light. Look at your questions again. Your questions want you to prove that CM squared over DC squared. Now, I need to find CM squared. That's what I don't have. So, if we look at triangle AMC and we look at triangle MCD, would you agree that those two triangles are similar?
Yes, sir.
AMC is similar to CMD, and I can prove it to you. A1 is common, agreed?
Yes, sir.
And then we have AMC and we have CMD. Both are 90. No, A1 is not common, guys. That was a mistake.
Oh, yes, sir, because
M is common.
smaller.
Would you agree that M is common?
Yes, sir.
And then we're looking at the red triangle and the blue triangle. Can you see that A1 is 90 minus X, AC2 is 90 minus X? And we just proved it. Oh, if you
Yes, sir.
wanted, I also found this whole angle was X previously. So you could have used that X and D2, but they're similar. Now, what ratios do we get out if they are similar? Can we write down the ratios here?
Yes, sir.
AM
CM over MN.
and guess what? I want to use this too. Because what will happen if I use that too?
You wouldn't get the CM squared.
We'll get the CM squared we're looking for. Can you see that?
Yes, sir.
Okay, so I'm going to delete that just to give you some background. So if you write down your ratios, that's the two ratios I'm interested in. And when you cross multiply this two, when I cross multiply, what is CM times CM? CM times CM, isn't CM times CM CM squared?
Yes, sir.
And then you're going to multiply AM times MD. Can you see what I come up with? Now,
Yes.
look at the question. The question wants us to prove that CM squared over DC squared. So we're going to take this red rectangle here and divide it by the top rectangle. If we take this divided by this, let's look what happens. So CM squared
MD
over DC squared, CM squared is equal to AM times MD over AB times MD. And you'll notice the MDs will cancel off. Oh, sorry. And if the M's cancel off, what are we left with? We'll be left with
AM over
CM squared
BM.
over DC squared is equal to AM over AB. And that's what they actually want. Take some time to look at that. Okay, that was a little bit of a high level question, so stay with me. Now, CM squared over DC squared is equal to AM over AB. Now look at the next question. The next question wants you to prove that AM over AB is equal to sine squared X. But we just found AM over AB, which is CM over DC. Now look at the diagram, which is CM over DC. So we want to find out what is sine X. What is sine X in the blue triangle? Who can tell me what is sine X in the blue triangle?
Sine X is
Opposite.
opposite of a hypotenuse.
Would we agree with that?
That'd be-
So what is the
Yes, sir.
opposite?
So it'd be MC over DC.
Which is actually MC squared, agreed?
Yes,
Over
sir, over DC squared.
MC squared over DC squared.
Which is equal to AM over AB.
Actually, MC, let's rewrite it so it looks nice. MC is actually CM squared. So that's common. Therefore, we can say AM over AB is equal to, no, wait. There's a mistake there. What is my mistake? I just want to go back there. Let me just erase that. I forgot about the square. I shouldn't have put the square first, all right? Let's go back. One track back. So we are saying, what is sine X? Sine X is actually equal to opposite. CM, agreed,
Over hypotenuse.
over hypotenuse,
over
which is DC.
DC.
And if we want to find the square, then we're going to square both sides, which gives you CM squared over DC squared. You happy with that?
Oh, yes, sir.
Okay, but that and that is the same. Can you see that? So therefore, we can now conclude that sine squared X is equal to that circle, which is equal to that, which is actually equal to AM over AB. So that was quite a challenging level 4 question.
Oh, yes, sir.
Kirsten?
So it's not sure.
Okay, so let's move on.
Sorry, sir.
Yes.
So I think there's people waiting in the waiting room.
Oh, sorry.
Yes, sir.
They must come on time to class, or the doors are locked. The virtual doors also get locked. Anyway, let's move on. Okay, we're going to do some ratio and proportion now. All right, very interesting question in ratio and proportion. Because that's the problem area in the paper.
Yes, sir.
So let's read this question. In the diagram below, BC is 17 units. Can everyone see BC 17 units? BC
Yes,
is
sir.
also the diameter. If BC is the diameter, let me underline an important word for you.
Half of it is the radius.
Yes, no, I wasn't looking for that. That's diameter. What do you think I'm looking for? Not that you're wrong. Wouldn't that angle be 90?
Right angles. Yes, sir.
Very good. Angle in a
Angles in
semicircle.
semicircle.
Then it tells us that BD is 8 units, correct? We have a tangent. I'm looking for tan chord theorem. Let me just mark it there. I know that angle has to be equal to C, so we have a tan chord in place. Also, a radius is perpendicular to tangent. Did you know radius is perpendicular to tangent?
Yes, sir.
So angle B is also 90 degrees. Can you see that?
Yes, sir.
But anyway, calculate with reasons the length of DC. What am I going to use to find DC?
Pythagoras.
Pythagoras, well done. So what is Pythagoras saying? For those of you who are not seeing that, let me highlight the triangle for you. So if we look at the right angle triangle, and that's the yellow one. So we have 17, and we got our 8, so we can use Pythagoras to work that out.
It's
All right.
15, sir.
So we should be saying DC squared is equal to 17 squared minus 8 squared, with a lovely reason called Pythagoras.
Okay.
And then from there, you can use your calculator.
It's 15, sir.
You got 15. Well done. So how long is DC? 15 units.
15 units.
That was the easy part, all right? Let's go to the next question. It says, E is a point on BC such that we have a ratio of BE is to EC. And what is the ratio? BE is to EC, it's a 3,
3 is to 1.
R is to 1 R, right? It's a 3 is to 1. I'm writing 3 R and 1 R because it's not 3. It's in a ratio of 3 is to 1. It could have been a 6 is to 2. You with me?
Yes, sir.
And then they tell us that EF is parallel. As soon as they tell you parallel lines, can you see the triangle? You see the yellow triangle and you see parallel lines. What theorem is coming to your brain immediately?
Proportionality. sir.
Proportionality.
Int theorem. Now, what is the prop int theorem actually saying? Just to make sure we're all on the same page here. The prop int theorem was basically saying that if we look at CF over FD, what will the ratio be?
C would be CE over CB.
But we have the measurements, right? That's 1 R over 3 R. The R's will cancel off. It's a 1 over 3. Would you agree with that?
Yes, sir.
And that is your prop int theorem. But anyway, that's not the question. I'm coming to the question. The question is to find CF. So we're going to now go back and I'll start with this question. So if the question is to find CF, we don't have FD, so we're not going to use FD. So we'll take the whole side, which is 15. We can say CF over 15 will be equal to, who can tell me what?
So we'd say 1 R over 3 R.
It's EC over CP. So
Yeah, I want to know in terms of the ratio. Wouldn't it be a 1R over 4R? Total is 4R, so we can cancel off the R's, which is a 1:4. Am I right?
Oh, yes, sir.
Because we're taking the entire side now. And then you can cross multiply and you can say CF is equal to, sorry, 4CF is equal to 15. So therefore CF is equal to 15 over 4. Anyone's got a calculator there? That's 3 3/4. Am I right?
3.75.
Okay, so that's how we find CF, which is a 3.75. How
Sorry,
long
sir.
will, sorry?
So aren't we not allowed to use the ratio compared to the actual units?
I'm not with you.
So you made the ratio equal to the actual measurement.
Yeah, because I use the R and then I cancel the R's off.
Oh, okay.
But let's
Thank
do
you,
it your
sir.
way. I just want to show you what I know what you're talking about. You can use the ratios. I used R. I didn't use it without the R, but your R's will cancel off. Are you with me?
Yes, sir.
But if you want to do it another way, you know this entire side is 17 units. All right, and the ratio is 1:3. That means there's 4 parts. So to find each one, if you're trying to find EC in terms of a measurement, right? If I'm trying to find EC in terms of a measurement, you'll have to take your 17 and divide it by 4. And
It's
then
4.25.
it's 1R, which would be times 1. What will you get?
4.25, sir.
4.25. And to find BE, you will say 17 over 4 times its 3 parts. Or you could take 17 minus 14.25, but I want you to just use that. What did you get here?
12.75, sir.
Okay. So if we know those 2 units, we could actually work it another way and say, right, FC, or CF, sorry, could say CF over 15 is equal to, now we found the units, which was 4.25. So I'm going to take 4.25 over the entire side of 17. Can we cross multiply calculators out? CF times 17 is 17 CF. What is 15 times 4.25?
It's 63.75, sir.
And then we're going to divide both sides by 17. What do we get?
3.75, sir.
And you see you're going to get the same thing,
Yes, sir. Just longer.
just longer.
So which one do you think we should use for the test, or which one's allowed in the test? So,
Well, it doesn't matter. Both are
so we can
allowed.
use the one on the test.
Yeah, both are allowed. Okay, let me go back to the first method because I think some of you got confused there. What I said is CF over 15 in terms of ratio. It's actually 1R over the entire side. The entire side is actually 4R. So I haven't used 1 over 4. I used 1R over 4R. And what happens? Your R's cancels off. You're with me now.
Yes, sir.
All right. This is much more
Yes,
easier.
sir.
Okay.
Do we need to show the R, sir?
Sorry?
We have to show the R, sir, and the cancelling of R to get the
No,
mark.
you don't have to. You don't have to. In this case, you don't, because in your brain, you can cancel it off. It's a ratio 1:4. You could have used a ratio direct 1:4. We'll accept that. Okay. Next question.
Yes, sir.
Oh, I lost a lot of things now. Where did I lose that? All right. The next question. So you can keep the measurements. I might need it later. So please keep those measurements. Let me erase my board. Are we learning something on ratios here?
Yes, sir.
Well done. So basically in ratios, you're looking for a triangle which has parallel lines, and then you can use your prop int theorem. Next question is to prove that BAC. Okay, I just want to get rid of some. All right. Let's get a highlighter. We're going to find BAC. BAC is a big triangle. And we're trying to prove that that big triangle is actually similar to FEC, which is a small triangle. Agreed?
Yes, sir.
All right, we need three things. Anybody found three things that are equal there?
So the C is common.
Very good. Are you sure? Yes, you are sure. All right, number one. Let's write that down. Number one, somebody said angle C is common. Okay, we need a number two.
Mm,
Why, if someone told me that if someone told me that B1 is a tan chord, can I just write this down for you guys? What if someone told me B1 is equal to angle C instead of telling me C is common, and they told me tan chord? Will we accept that?
no, sir.
But B1 is equal to angle C. That is the tan chord theorem.
But it's not
So
the whole
why are
angle of
we-
B, sir.
Sorry?
It's not the whole angle of B.
Yes, we're looking at the entire angle of B, not B1. B1 is not part of the three angles we're dealing with in the yellow triangle. So that's why we were not accepting that. All right, but anyway, coming back to number two. Anyone's got number two?
Hmm.
So would B equal 90?
B is equal to?
Oh, yes,
Wait,
if B was equal to 90, would it not be?
Right. Let's write
Because
that down.
AB is a tangent.
Let me write that down. Let me write that down quickly. Right. You guys are telling me B is equal to 90 degrees. Well done. So angle B is
And
equal
then-
to 90 degrees, and that is your radius is perpendicular to a tangent. We're happy with that. Carry on.
D is equal to 90 degrees because of angles in semicircle.
Okay, we all got that. Let's call it D1. So D1 is equal to 90 degrees, and your reason there would be angle in the
Angles in
semicircle.
semicircle. And then F is equal to 90 because of corresponding angles.
So let's call it F1, all right? Are you all happy with that? Then angle
Yes, sir.
F1 is equal to 90 degrees, equal corresponding angles, and we should be stating that BD is parallel to, I think, EF. And therefore, we come to the conclusion we want to make. And the conclusion we want to make is that angle B is actually equal to angle F1. Agreed?
Yes, sir.
And then we need a number three.
Angles of a triangle.
Some angles of a triangle. We just got to pick out the missing angle. I think in a yellow triangle, it should be A. And in a green triangle, we have E1. Make sure
Yes,
you call
sir.
it
And
E1.
then E1.
E1. All right, I put a 1 there. You're allowed to put labels on your diagrams, 1 and 2. And therefore, it is similar. In your case,
Similar.
A.
Angle,
A.
angle, angle.
That was a good question. Don't you think so? You had to do some work for that number 2 is here. Didn't come easy, am I right?
Yes, sir.
Yeah.
Definitely.
All right, let's get to the next question. And the next question said, calculate the length of AC. Any ideas?
Is it not possible to do Pythagoras, sir?
AC squared is equal to BC squared. We have BC 17, AB we don't have.
Oh, yes. So we could
Yeah,
do
right.
similarity, proportional.
Yeah, let's
propor-
go similarity. Let's see what ratios we get out. Can we look at the ratios coming out there? So
Yes, sir.
we should be saying AB over EF is equal to BC over FC, which is equal to BC. Oh, I said BC, sorry. I took AB, I took BC over FC, last two. So I should be taking AC. Are you happy? Now they want us to find AC.
Yes, sir.
Which ratio has AC? So definitely you have to use that, am I right?
AC to EC,
Ah.
yes, sir.
Now let's see what else we know. Do we know what's AB? No.
AV, no, sir.
Let's go to the next one. Do we know what's BC?
Yes, sir.
BC is
17.
BC is 17. That's a good help for us. Do we know what's FC?
Yes, sir. 3.75.
We worked it out, 3.7. So that's a good one to use, all right? So we can conclude now. And I'm going to actually, oh, that's bad. So let me take, all right, we're interested in this too. So we said BC is 17, FC is 3.75, AC we don't know, that's what we're trying to find. Now let's go to EC. Do we know what's EC?
Yes, sir.
Yes, we worked it out. It's 4.2.
25.
And we can cross multiply. 3.75 AC is equal, calculators out, 17 times 4.25.
It's 72.25, sir.
And then you're going to divide by 3.75. What do we get for AC?
19.27.
I hope he's right. Anyone is checking there?
Yeah, he's right, sir.
Okay. Now, last question. Take all this jargon out. We come to the last question. It says, write down, giving a reason, the radius of circle passing through A, B, C. Any comments?
So do we have to draw the circle?
No, it's already drawn for you.
But it doesn't pass through A.
Oh, you got a picture it, right?
So would it be 17?
How can you make a statement like that? It's 17.
So because I can never mind, so I'll see.
So they try to tell you that there is a circle passing around what? You got it?
A, B, C, yes,
Now,
sir.
there's something very important that we need to see. If angle B is 90, the converse will make AC what?
The middle diameter.
Very good. Therefore, AC is actually, would you agree with that?
7.5 of that.
Okay.
Yes,
Because
sir.
angle B is 90, that makes AC a diameter, which means half of AC would be the radius. So therefore, we can now conclude that
radius.
the radius is actually 19.27 and divide that by 2, and that will be a radius.
9.635.
Are you guys with me?
Yes, sir.
Yes.
Sorry, sir.
Yes. Question? Somebody wanted a question? Can you hear me out there?
If you don't mind, sir.
Sorry? Sorry, I didn't hear anything you said.
Yes, sir.
What's your question,
Sorry,
Sasha?
sir.
Sorry?
So would you mind adding back Dawson?
Oh, okay. I've just done it.
Thank you, sir.
We are on a little higher level, guys. Yesterday, we're dealing a lot with grade 11 stuff. Can you see I've gone a lot into grade 12 stuff today? So if you weren't here yesterday, I'm sure you'll be able to catch up with that video. Matthews, are you with me?
Yes, sir.
Because you got a message here, you can't hear me. Oh, you can hear me now.
Yes, sir. Yes, sir.
All
Check.
right, let's go to the
Can you
last
quickly
question.
go to the last?
All right. In triangle PQR. Okay, guys, before we do this question, let me just revise some things that are very important pertaining to what we want to do here, right? We always tell you this, all right, and it's quite famous. We always tell you, oh, these two lines are parallel, and you all get very excited. And what do you conclude? You will now conclude the ratios will be the same. Am I right?
Yes, sir.
Famous question, and you'll all be able to tell me from this, you'll be able to tell me AB over BC is equal to AE over ED. That's the given. That's not a catch question. Because the lines are what? Parallel.
Parallel.
Okay, now let's go converse. Now you better start watching converse. So in a converse situation, so if I tell you that A, B, C, D, E. So if I tell you AB is to BC is actually equal 1:3, and I tell you that AE is to ED is actually equal to 1:3. Oh, I could have told you in this way. That's a 1/3 and that's a 1/3. What is your conclusion?
That they're proportional to each other.
Right, but what's your conclusion in the triangle?
That C, D, and BE are parallel.
Well done. So you must be able to conclude because the proportion, because they're equal, all right? So in other words, what we're saying is, if that is true, therefore AB over BC is equal to AE over ED. In other words, the ratios are the same. And if the ratios are the same, then you can now conclude that those two lines have to be parallel. Can you see how I'm using the converse?
Yes, sir.
Now, hope you're writing notes. I won't be wasting my time doing all this, okay? It must be very important, everything I'm doing. Now, let's talk a little bit about the midpoint theorem that happened in grade 10. You know about the midpoint theorem?
Yes, sir.
Now, if we look at a midpoint theorem, so the midpoint theorem states if you've got a midpoint sitting on this side, that means if M is a midpoint, and then if you've got a midpoint sitting here, what is your conclusion from the midpoint theorem? Sorry.
It's the lines are equal. Then
If you've got a midpoint theorem, can you see that? Your conclusion is,
the
oh, sorry. The conclusion that these lines will be parallel.
yes,
or
sir.
no? And the midpoint tells us a little something further. If this is 10, then that'll be 20. That's the midpoint theorem now. Don't confuse it with ratio and proportion. But midpoint theorem, what will the ratio be here? If it's a midpoint theorem, if M is a midpoint, the ratio will be 1:1. Agreed?
Yes, sir.
So if AS is 5 units, how long will ST be?
ST.
5 units. Because you want a
Yes,
ratio of 1:1. Anyway, it's a midpoint, all right? Now, I'm just doing some revision here now on midpoint theorem. So let's get to the converse of the midpoint theorem. Have you heard of the converse? This is all grade 10 work.
Yes, sir.
So the converse says, all right, if M was a midpoint and this line was parallel, what does the converse now imply?
The converse would say that
That becomes the
opposite sides
midpoint.
are equal.
Yes, that
Yes,
means
sir.
P will be a midpoint. In other words, AP will be equal to PC. That's called a converse. Okay, saying all that, I hope you caught some midpoint theorem from grade 10. Now, let's go to our question. So, in triangle PQR, A is a point on PQ such that PA is to AQ. So they're telling us we have a ratio of 5. Those of you don't know where I'm reading, I'm saying 5:4. Are you happy with that?
Yes, sir.
So we have a ratio of 5:4. Now, R is just to tell you it's not actually 5 units, all right? Here's a point on PR such that PB is to BR. PB is to PR, okay? And on this side, we got a ratio sitting at a 5.
5:2.
5:2, but we can't use the same letter just for convenience. We'll say we use R there, just say P and P. Okay. And the story goes on, but a very crucial point is made here. It says S is the midpoint of what? Of AQ.
Of AQ.
So what does it mean to you?
That
AS is
How many
K
R
is
will
the midpoint
AS
of
and
X.
SQ be? Sorry?
AS is to R.
Are you happy with that?
Yes, sir.
Because the whole thing was 4R, we're going to split it down and get a 2R is to 2R. Okay. And then the first question is prove that QT is actually twice RT. So, where are we going to go with this?
Oh, we'd say that AB and SR are parallel.
I like that. Somebody saw something. Can I highlight the triangle for people who did not see that? Oh, that's not a highlighter. So the young man that is talking now, he's telling me, look at this triangle called PSR. And because the ratios are the same, can you see that? For those of you who cannot see that, let's write it down. PA, it's a bad color. So we can say that PA, oh, sorry, so one black. So we got
Yes, sir.
PA over AS, agreed? Is actually equal to 5/2. Would you agree with that? Hello, is anyone listening to me there?
Yes, sir.
So PA over A, it's on a diagram, it's 5R over
Yes,
2R,
sir.
the R's will cancel out. But if you look on the other side, you also have
Yes, sir.
PB
Yes.
over BR, which is also a 5P over 2P, which is a 5/2. So what is my conclusion? Therefore, PA over AS is actually equal to PB over BR. And therefore, because the ratios are equal, what can I conclude? AB has to be parallel to SR. That is what the young man was trying to tell us. I don't know why. So we want to put your parallel lines here. Are you happy with that? What you trying to tell me?
Yes, sir.
Anybody else? Is anybody else with me there? Are we lost?
Yes, sir.
What are you lost with?
Not lost, sir. I'm with you, sir.
Very good, very good. People are with me. That's what I like to hear. Okay. That you're not against me, but you are with me. Now,
With me.
where do we want to go from there?
Maybe we would say that BT is parallel as well because AB is parallel.
Very good. It's the same line. Now let's draw that for people who cannot see that. See, color is very important to see in this one. It's actually quite hard to see. So now I'm going to take this. Oh, that's not the color I wanted to use. I'm going to erase that. Get a highlighter, but change the color to purple. So can everyone see this purple triangle I'm drawing?
Yes, sir.
Isn't this purple line SR is actually, it's the same line. It's parallel to AB. ABT is a straight line. So what can we conclude? If now we're
Yes,
going to
sir.
use ratio and proportion. If those lines are parallel, what conclusion can you make?
So that QR is 2R and then RT is 2R. So therefore QT is equal to 2RT.
Very good. But now, isn't that a midpoint? Look closer.
Oh, yes, yes.
Isn't that a midpoint? So we have a midpoint, we have parallel lines. What does it make R? It makes R a
Makes
midpoint.
R the center, yeah.
Yeah, even if you didn't know that, it's fine because let's go to the question. We only use Q. The question says QT and RT.
RT.
So if we use the ratio, if you use the ratio, you can say QT, because the question wants QT, over RT. Now QT is the whole side, which means I must take AQ on the other side. And then I took RT, the second part of the side, which is actually over SA. Now AQ is actually 4R, and SA is 2R, which is actually giving you, don't need to use the R's. Can you see that? So in other words,
Yes,
we
sir.
got QT over RT, and 4 divided by 2 is 2 over 1. Cross multiply, you would get QT is equal to RT. Are you with me?
Yes, sir.
Good
Yes, sir.
question. And then we go to the next part of the question. Now the next part of the question wants you to prove that AT is twice SR. Well, actually, that's the midpoint theorem. And if you want to write that down, what you would say is QS is actually equal to SA. How do we know that? That was given, am I right?
Given, yes, sir.
And then we proved that SR was parallel to AT. So proved above. Therefore, we can conclude that QR is actually equal to RT. In other words, R is the midpoint, and that is the converse of the midpoint theorem.
Almost.
And therefore, the midpoint theorem states that SR or AT would actually be twice of SR. And that is the
Yes.
midpoint theorem. All right. A nice question, on proportional intercept. So watch the recording again if you lost. I'm going to take this out. We go to the last question. Number 3. So in number 3, okay, I'm going to take this out now just to make the diagram a little bit more clear to you. Hope I don't need it. So we're going to the highlighter. It tells us that RK, let's use a blue. We haven't used a blue. It tells us that RK, if RK was parallel to QX, so that line is parallel to that. Let's actually complete the diagram. Now we just found the ratio. I think we found the ratios, but we didn't write it down. So the ratio here, QR is to RT is a 1:1. Am I right? Because R was the midpoint.
Yes, sir.
They want to know what is PX is to XT.
X is to X.
Okay, so PX is to XT. So let's look at this.
We can
We
find
can look at the other
A.
triangle. That's a 5/2. If we actually draw that, but that is not parallel to that. Okay, I'm with you. All right. So if we look at the blue triangle, what will be the ratio of XK is to KT? Wouldn't that also be a 1:1?
1:1, yes, sir.
Let's just give it a letter. 1M is to 1M, all right? Because it's a midpoint. Can you see the lines are parallel? So your ratio
Yes,
will be
sir.
the same. But that doesn't help us. We want to find out what is PX over XT.
So would PX not be 5?
Why?
Because QX is parallel. Oh, no. That means that would be 9P.
All right, let's go to the other triangle. We have to actually go into, to see that, we need to go
So
to
it'd be
the,
9.
let me get a highlighter on. And can everyone see this new triangle I'm trying to draw here in yellow? Oh, that's not coming nice. Okay. Just want to clear that out so that you can see it. We're going to go with a shocking purple. All right. We want to
Yeah.
find out what is PX over XT. So I don't know what's PX, all right? So if we look at this triangle here, the purple,
So wouldn't
right?
XK equal 2M?
Sorry.
XK equal 2M because of the parallel lines. Then KT also equals 2M because midpoint.
XK is equal to
2M.
but we said XK was 1M. It's a ratio 1:1.
Yes, sir, but wouldn't it also be 2? It could be 2, sir, because of parallel lines of BR.
You got to compare it to, we're comparing ratios here. Okay, let me just put it this way. If I want to find PX over XK, you're trying to tell me? I'm not
Yes,
with you.
sir.
Dawson, we're looking
when
at
you
the
just
triangle.
it's 2.
We're looking at triangle QXT, Dawson. So QXT, that's the triangle we're
Q-
looking at to get X.
No. But anyway,
Oh,
what
never
would
mind then.
PX over XK actually be equal to? That's what I want to ask you.
9M is to 2M.
Hey, how did you get 9M now?
Would not be the 5R plus the 4R.
Oh, you're looking at the big triangle.
Yes, sir.
And you're looking at it from which side now? That line is parallel to that. I would have thought if you were looking at PX over XK, I'm looking at the purple triangle. Isn't that a 5/2?
Oh, okay, yes, sir.
Okay. But we know xk, we say that xk is actually 1m over 5 over 2. Agreed?
Yes, sir.
And to get rid of that, we can actually say that px is actually equal to 5 over 2 cross multiply m.
Okay, sir.
Are you with me now?
Yes, sir.
Because I brought it in terms of m. Now, what is my question?
Px is to xt.
Now we can find that surely. For those of you confused, all that wants to know is what is px over xt? And all we have to do is what is our px? Because we have the same letter now. 5 over 2m, am I right? Over what's xt? 2m. And what is 5 over 2 divided by
Yes,
2?
sir. Xt is 2m.
It's 5 over 4. Agreed?
It's 5 over 4. Yes, sir.
All right. Therefore, we can say that px is to xt, which will actually be equal to a 5 is to 4. Okay, so this question was very complicated, dealing with all the ratios. But the good thing is we have a recording so that you can go back and revisit these questions. So I see some people joined us very late. I just let 4 people in. So you guys came in late. Unfortunately, we did some very high level questions today. The good news is I'm going to post this recording. Please watch it because there's some very important, especially if you're in your my class. This is a direction I'm giving now from my class. Go over the questions here. They're very important. It'll help you for tomorrow's paper, okay? Are you all okay with that?
Yes, sir.
All right. So,
Yes, sir.
yeah, a lot of you came in late. Please go through this presentation. The questions are quite good here, high level. I even went and concluded the last 2 or 3 questions on the prop in theorem. If you don't go through some of these questions, you'll really struggle in tomorrow's paper in terms of prop in theorem. So I'm going to actually end the session now.
Sir, I've got a question.
And I'm going to post this video up because I want people to watch them as soon as possible because you're writing tomorrow. So I don't want to post this video late today. Okay, let me stop the recording, then I'm going to take a question, but I want to stop the recording now.
Sir,
Be with you now, young man. Okay.